these chips yet, so you're going to help them out with money along the way. That leads some people to think back to what
we would need to train the models and
started the AI race, and as President of the United States, I'm here today to declare that America is going to win it.
Everyone wants to win the AI race. Tech conglomerates, sovereign states, entire empires. Billions of dollars are pouring into artificial intelligence. New data centers are rising across the world. And every few weeks, a bigger model, a bigger investment, another breakthrough. But beneath all the headlines, beneath all the promises, the race is actually about one thing. There is one machine on Earth that can print the circuits inside every advanced AI chip, every GPU in a data center, every chip powering ChatGPT, Gemini, and every large language model running today. One machine, one company, one country. And for the last 4 years, the United States has been fighting a war to make sure China never gets access to it. This is not a trade dispute. This is not politics. This is a battle over the most strategically important machine ever built. And whoever controls it controls the future of artificial intelligence. The company is called ASML. Most people have never heard of it. It is headquartered in Eindhoven, a mid-sized Dutch city, most famous for a football club. It employs around 40,000 people, and it holds a monopoly over the single most critical piece of hardware in the entire semiconductor supply chain. ASML builds EUV machines, extreme ultraviolet lithography systems. These machines use laser light, with a wavelength of just 13.5 nanometers, shorter than any visible light, shorter than X-rays, to etch circuit patterns onto silicon wafers with atomic precision. Circuits so small that 10,000 of them fit across the width of a single human hair. Without EUV lithography, you cannot manufacture the chips that power modern AI. Not at the performance levels that matter, not at the scale that matters. And ASML is the only company on Earth that knows how to build them. Not because they got lucky, because the engineering is so complex, so expensive, and so dependent on a 30-year accumulation of proprietary knowledge that no competitor has come close. One EUV machine costs $380 million. It takes 40 shipping containers, 20 trucks, and 3 cargo planes to deliver. It contains over 100,000 precision components, sourced from suppliers across 5,000 companies worldwide. And it took ASML over 2 decades to make it work. To understand why this machine matters, you need to understand one law, Moore's Law. In 1965, Gordon Moore, co-founder of Intel, observed that the number of transistors on a chip doubled roughly every 2 years. More transistors, same size chip, more computing power. That compounding continued for 50 years. But by the mid-2000s, the physics started breaking down. The tools used to etch circuits onto silicon, older DUV lithography systems using deep ultraviolet light, were approaching their physical limit. Light has a wavelength, and you cannot print a circuit smaller than the wavelength of the light you're using to print it. Engineers were hitting the wall of physics. The solution required moving to shorter and shorter wavelengths of light. Extreme ultraviolet, EUV, is so short, it is absorbed by almost everything. Air absorbs it. Glass absorbs it. Water absorbs it. To use EUV light in a manufacturing environment, ASML had to create a near-perfect vacuum inside the machine. Build mirrors precise to the diameter of a single atom, and generate the light itself. using a laser that fires 50,000 tin droplets per second and vaporizes them at 500,000 degrees Celsius. This is not engineering at the edge. This is engineering beyond what anyone thought was buildable. And it works. For decades, the global semiconductor supply chain operated on a simple assumption: specialization, interdependence, mutual benefit. Taiwan made the chips. ASML made the machines. US companies designed the architectures. China assembled the consumer electronics. Everyone needed everyone. Then something changed. In 2017, the Chinese government released its new generation artificial intelligence development plan. The goal was explicit: by 2030. China intended to become the world's primary AI innovation center. Not a competitor. The center. And every serious analysis of that roadmap pointed to the same bottleneck: chips. Advanced semiconductor manufacturing. The ability to fabricate the processors that AI runs on, domestically, independently, without relying on foreign suppliers. That could be cut off. China's largest chip maker, SMIC, was already manufacturing chips for domestic use. But it was generations behind TSMC in Taiwan, generations behind Samsung in Korea. To close that gap fast, China needed EUV machines. ASML had already been selling older DUV systems to Chinese customers. 28 machines shipped to Chinese fabs between 2018 and 2020 alone. The EUV machines were next on the list. They never arrived. In 2019, under diplomatic pressure from Washington, the Dutch government quietly declined to renew ASML's export license for EUV systems destined for China. No public announcement, no press conference. The license simply did not come through. ASML never shipped a single EUV machine to a Chinese customer. And that decision, made in a government office in The Hague, set the stage for the most consequential technology war of the 21st century. October 7th, 2022. The Biden administration published what analysts called the most sweeping export control action in decades. The rules were surgical in their targeting and brutal in their scope. No U.S. company could sell advanced chips or the equipment to make them to Chinese entities without a license. That would almost certainly be denied. No foreign company using U.S. technology, which includes almost every chip company on Earth, could sell to China either. The so-called Foreign Direct Product Rule extended U.S. jurisdiction beyond U.S. borders. TSMC in Taiwan, U.S. rule. Samsung in South Korea, U.S. rule. ASML in the Netherlands, U.S. rule. Because their tools, their software, their designs all contained American intellectual property. The semiconductor supply chain, built over 50 years of global interdependence, was being weaponized. And it went further. American citizens and green card holders working in Chinese semiconductor companies were told to choose. Stay in China, lose your citizenship protections, or leave. Within weeks, hundreds of American engineers walked out of Chinese chip fabs. The institutional knowledge they carried, process recipes, calibration techniques, yield optimization methods, walked out with them. China's semiconductor industry didn't just lose access to hardware, it lost people. China did not concede. The state response was immediate and enormous. Beijing launched what became the largest state-funded industrial program in semiconductor history. The China Integrated Circuit Industry Investment Fund, known as the Big Fund, poured capital into domestic chip makers, equipment manufacturers, and materials suppliers. The target was clear: replicate the supply chain that had been cut off. Build a domestic EUV equivalent. Build domestic chip design tools. Build domestic advanced fabs. Then, in August 2023, something unexpected happened. Huawei released the Mate 60 Pro. Inside it, a 7-nanometer chip, made in China, by SMIC, without EUV machines. The engineering community was stunned. SMIC had achieved 7-nanometer yields using older DUV lithography, a technique called multi-patterning, where you expose the same wafer multiple times, at different angles, to effectively achieve a smaller feature size. It was slower, more expensive, lower yield, but it worked. The chips weren't competitive with TSMC's best. They weren't close to what NVIDIA was producing, but they existed, and they proved something important. China could not be stopped, only slowed. Here is what this is really about. AI capability is directly correlated to compute. More chips, more powerful chips, more AI. The systems being trained on NVIDIA's H100 and H200 clusters, the ones powering frontier AI research, require hundreds of thousands of advanced GPUs running simultaneously. That is not possible without TSMC's 3-nanometer and 5-nanometer process nodes, which are not possible without ASML's EUV machines, which China cannot buy. This is the choke point the United States built. And it is not just about commercial AI. Autonomous weapons systems, drone swarms, electronic warfare, hypersonic targeting systems, nuclear command and control. Every next-generation military capability runs on advanced semiconductors. The country that leads in chip manufacturing leads in military AI. The country that leads in military AI in the assessment of every major defense think tank holds a structural advantage in 21st century conflict. This is why a lithography machine in Eindhoven became the center of a geopolitical war.